Alright, now this was 5. Then other one, MA2B2C2. This is a bit tricky as sort of standard. Well, their forms. First one we'll see as A B C C. This is one. ACBC. The squared and then ACBC. Okay, same. Now this is one. This. Now I'll just try to, you know, do the trans configuration in this plane. So C and C here. Now ACAC. ACBC, no. ABAB. So this is also different. This counts as one. Now other one I'm going to do it like this. M and then here. Now the here C was opposite. Now I'll do C is adjacent. A as adjacent. B opposite. Now this compound here is ACCA ABCB ABCB ACBC. No. So this is also different. One. And now M. Now instead of this, I'm going to keep all of them like here AA, BB, CC. The pair B, B, C, C, A. Right. So these are together. So it's cis configuration. Now this has 2. The reason is it's not symmetric through any axis. Not this, not this, not this, not this. Alright. Now the other one, how to do it. So here A and B were cis. Here nothing was cis, everything was trans. Here A and C is cis. B and C cis is remaining. Let's try that. B B C C A A. So B A C A. B A C A. Now is it anywhere? B A B C, no. B A B C. B A B B C C, no. I guess so. These are kind of similar. C A B A B A C A B A B A and then B C B C, no. So this is a different one. Clearly, for checking that out, we compared with these. Now of course it's not equal to this anyhow, because BACA, BACC and then BBAC, no. So there are 1 1 1 1 and then one enantiomer pair. So overall is 3 4 5 6. Alright, now we have done these many. Let's now switch to when bidentate ligands are there. So for bidentate ligands, it's sort of tricky. Alright, this one's a lot tricky. I haven't done this before, but let's try it together. Oh. So this one will start with A and B aside, B, and C and D. Now here it's of course symmetrically possible, so no no enantiomer pair. Now let's try to switch A and B here as trans, A, B, B, and then here y'all can see this is hope so not symmetrical, which makes it okay. No, it's symmetrical from this. If we cut B and B, so it's not an enantiomer pair. Now let's try to put C and D aside each other, C D, and then A, B, and B. So here it's not symmetrically cuttable. I mean, not symmetrical through any plane. Oh no, this plane B and B symmetrical. Mistakes happen, that's why this topic is so hard. Anyways, A B D B, A B D B, A B no. So A B no, it's not possible. Now B and B are opposite. Here also B and B were opposite, but C and D here are aside. Now C and D are aside. Now let's do B and D aside and C and D aside. B and B aside and C and D aside, and then A and A opposite. Opposite. Hope so these are not same. Let's see, B A D A, B A B D. Okay, no, it's different. So 1 1 1 1 1. Okay, now let's try to see another one. Hope so this is visible here. Alright, now we have to use our brain and put them all into cis. Assuming C and D together, basically C up and metal here, D here, B here, B here, A here, A here. All of these are aside and cis. Assuming this C and D same, which are not, but still, because here it followed the same pattern. These were all cis, B and B, A and A, C and C. Alright, now here we can see it's not symmetrical through any plane, thus 2. 1 2 3 4 5 6, and I hope so there are many different ones. Let me use a rough paper for that. Alright, now let's try other ones as well. Okay, so here it was like this. Now let's switch C and B just for checking if it would change anything. C and B are changed. Now C, B, A, D, and B. Okay, earlier D and B were never opposite to each other. We were just doing C, D, C, D, B, B, A, and here C, B. So instead of C, B, D, B are opposite. Alright, D, B are opposite. I guess this is different. A, B, B, D. A, C, B, D. A, C, okay, A, B, D, B, and A, B, B, C, A, B, A, D. Okay, no. So this type of compound is not anywhere, so this counts as 1. And also, it counts as 2. The reason is because you can see that it's not symmetric through any plane because it's unsymmetric, of course. So 2, 2, 4, 5, 6, 7, 8, 8, and 2 enantiomer pairs. Now also let me write this here, somewhere. So I guess so I can devise a plan or something. A, C, B, A. Now I guess B and D were opposite here, C and B were opposite, B were opposite, C, D were opposite, C, D were opposite, and yes, we could, when C and D were opposite, they are same, you can use cis and trans, which won't change anything. And so the answer basically is 8. Let me check from my book. Yes, the answer is 8, and enantiomer pairs are 2. Now let's try to find a short trick or a general approach. C, D are opposite, then these, the two compounds are same, then we can use cis and trans, making it 2. When BB are opposite, we can just see like this. Now we cannot exploit this and do AA opposite because it will be like this, right? If we make it opposite, we will get something like, let's try to make A opposite and C opposite. A, C and D, B and B. So we got something similar to this, I guess. A, B, A, B, A, D, O, A, D, A, C. Wait a minute. A, B, B, D. E, C, B, B, and then wait. We changed cis. Now let's check where BB are opposite. There's only one. And this, we didn't check this. So I guess it should be equal to this. Now let's see. BB. Okay. Yeah, it's the same. See, A, D, A, C, and here A, D, A, C. It's the same plane. That's why I'm going to generalize this. Firstly, we have to take two opposite compounds. Ligands like C and D, opposite side. Here cis and trans, we'll get 2. When same compounds are opposite, never try to do cis and trans. Keep these adjacent, then try with different C and B and check these are different or not. Anyways, I'm going to learn these values because these values will help a lot in exam time saving. Alright, then the toughest homework for y'all, M, A, B, C, D, E, F. That's the homework. Guess in the comments.